Welcome back, everybody. We have a very special session for you coming up. How to supercharge your product development with continuous delivery and serverless. And it's delivered by one of my favorite people, Alex Castlebani. This guy is so smart, he makes me dizzy. And he's one of the serverless experts in our community. So pay close attention, write plenty of good questions in Twitch, and I think you're in for a treat. Alex.
Thank you, Rob. Thank you, everybody. Welcome back to the theater. We are live from Collision for all of you back home watching on Twitch. Thanks for the great introduction. I'm also pretty jet lagged, so I apologize in advance. I come from Europe. So this session is about how to use serverless computing, how to use approaches and technologies like CI/CD, automation, continuous integration, and continuous delivery to speed up your development. And that's probably one of the most useful and most interesting advantages and benefits of serverless computing itself. So just 20 seconds of what I do. I'm a software developer. Who is a developer here today with us? Well, 100%. Great. I'm a developer too. I've done that in a startup for almost 5 years, and I've been using AWS for a few years as well, until I joined last year. So I'm very active in the serverless community. I even organize some events around the world. There is even one here in Toronto called Serverless Days. So there are more than 30 around the world. So if you're interested, if you like the topic, make sure you reach out and find out when it is in your city. The agenda for today is a little bit of background for those of you not completely familiar with the basic concept of serverless computing. And then I want to show you some patterns, some reusable patterns and interesting things you can do with serverless, some use cases, some customers, some stories to worth remembering. And then I actually talk about continuous delivery and what we internally call safe deployments. And so we can talk about what does it mean to be safe when you deploy new code to production, and what techniques and tools and services you can use to make sure, when you git push on Friday evening at 6 p.m. that everything goes all right, because that's what we do, right? And then I have live demo to show you what happens when things actually go wrong, because things go wrong. That's why we are here. So we want to help you, avoid those situations where you have to fix problems on a Friday evening at 7 p.m. So let's get started. Before we actually get started, I want to remind you that you can get all the slides of this AWS Theater if you visit this link. You can sign up for the slides. So even if you are at home and we're not here, we couldn't scan your badge, you can still have the slides just by signing up at this URL. It's a simple landing page for you to get the slides in the next few days. So if you attended a few sessions and you want to have your slides at your disposal on your laptop, why not? Cool. So what is serverless computing? I get this question a lot. And the answer has been evolving in the last 3-4 years. It's a mix of things. It's about not thinking about servers. It's about using services and thinking about architecture instead of code components and just writing every single line of code that composes your architect or your software solution. It's about using third-party services and delegating to a service instead of reinventing the wheel every time, so that you can gain agility and speed and move faster by owning less code, by owning less architecture and software and components that can break and that somebody else will fix for you. I don't know, for example, user authentication, user management, or queuing systems, or emailing systems, like all those things that now are so easy to use with an API call. Why should you reinvent the wheel or implement everything? And that's when AWS Lambda, our function as a service offering, kind of started this sort of serverless revolution back in 2014, between 2014 and 2015, by providing this compute service that was serverless for the first time, that could allow you to glue together these services and to build your your websites, your backends, your data pipelines. There are all sorts of use cases. But what do we mean by that? So there is we call it a spectrum. There is no real strict line between what is or what isn't serverless, but there are a few strict concepts. Like if you are connecting, SSHing into a server, or if you are dealing with Docker files, that's probably not serverless. Okay, the idea is that you don't have to deal, work, patch, provision, or maintain servers or containers when you work with serverless. And that is a lot of heavy lifting that you don't have to think about anymore. Think about patching the operating system, updating libraries, patching for security, vulnerabilities that come up every few months, they do. We take care of that for you. Basically, if you think about when you have instances and virtual machines, then you have containers, and then you have functions. So we talk about function as a service. So all you provide is your business logic, your code. As our CTO Werner Vogel said, all you want to write in the future is business logic, not reinventing the wheel and wasting your time and your develop resources, especially if you are a startup. If you have 3 developers, you don't want them to go and SSH every 2 weeks and patch the operating system. That's wasted time that they can use to build something that adds value to your customers and to your company, to your business model. And since we take care of everything below that level, everything below your code, that means infrastructure, networking, security, deploying your application to multiple data centers and multiple availability zones, as we call them internally, like logical data centers within the Amazon global network. We can take care of a lot of things for you. One of the advantages is the high availability that you get out of that, which means if you're running a cluster of machines, you have to take care that they talk to each other. If something goes down, it will come back up somewhere else in another availability zone or in another data center. Okay, we take care of all of that. It means your applications are more available, highly available by default. And that's just a problem you don't have to face or think about anymore. And another consequence of us managing the infrastructure is that you can scale down to 0, as well as you can scale up to infinity without having to think about all the complexity that usually comes with the scaling policies and cluster management and so on. So scaling up to infinity is great, because if you are a startup, or even if you're not, maybe you have spiky workloads, very hard to predict, but if you're a startup and you go viral and you get 100x traffic overnight, you want to be able to scale quickly without hiring more engineers or re-implementing your solution. That's key, especially in a startup. While scaling to 0 is also pretty interesting, because if you have spiky workloads, you don't want to over-provision for 6 hours, thousands of machines, but then you use them only for 2 hours and you're just wasting 60% of your budget there. Or if you're a startup and you have like 0 traffic for 40% of the day, which happens. I've built startups myself. It does happen. You don't want to pay a 24/7 server for doing nothing all day, just waiting for someone to come. So as a startup, again, you want to build new stuff. You want to build new ideas. You want to experiment with new features, or even just have multiple environments like development, staging, production, without paying for those machines 24/7. Here, the model is that you pay on a 100 millisecond interval basis. So if you run your code for 1.5 seconds, that's all you pay. If you run your server for 2 seconds and 600 milliseconds, that's all you pay. Okay? If you run your functions for 200 milliseconds, that's all you pay, right? And if you think about that, even working on cost optimization changes a lot with serverless, because imagine your functions are running for 110 milliseconds, and you can say, okay, this function is costing me a little bit. No, I want to reduce the cost, and so you're now paying for 200 milliseconds because we round it to the next 100 millisecond interval. So if you can shave off those 20 milliseconds and go down to 100 or 95 or 96, you're halving your cost just by taking those 20 milliseconds off your individual function execution. So thinking about cost, thinking about business model, thinking about compute optimization is a bit different, but it allows you to save a lot of money and to be flexible, highly available, more secure, and cheaper at the same time. Okay, I don't know about you, this never happens in IT. They can be faster and cheaper, more available, all together. Okay, so I'm pretty excited about this. Another point to stress is that you can finally build architectures that are event-driven. Okay, you can say anything happens in the system, like a new database record, a new user signs up, or a new file uploaded by my mobile application, you can react to those events in an event-driven way. You can say, when this happens, run this function, done. And then you can potentially orchestrate a series of events or functions generating other events, and you think in an event-driven way. You don't think about clusters and machines and protocols and ports to open in the VPC and things like that. It's a different way of building. I think it's more fun as well, because again, you can take these building blocks and design your architectures and put things together. What you can build with serverless. So I like to say this, that if you ask me a couple of years ago, I started with serverless around 3 years ago now. So if you ask me 1 year ago, I would tell you, okay, maybe we're getting there, but probably, I don't know, you can do 40, 50, 60% of new applications, you can build them on serverless. There is still some edge cases. If you ask me today, in the last 12 months, a lot has changed, like security compliance and time limitations, and even just the programming languages that you can use on Lambda today are different than a year ago. So if you ask me today, I would probably say more than 80 or 90% of applications are a very good fit for serverless. It could be a website, it could be an IoT application, a backend for a mobile app, it could be a data processing pipeline. Even, how many of you use Amazon Alexa here? Do you have an Echo device back home? Maybe a few? Okay, Alexa is built on top of AWS Lambda as well. So every time you talk to it, the text is passed to a Lambda function that does these stateless query or database, whatever it needs to do, that you build your own Alexa skills, for example. And it's a good fit, because it's serverless. Maybe you're not talking to it 6 hours a day, maybe you talk to it half an hour a day, or 10 minutes a day, and we want to optimize those compute resources. So there are a lot of interesting tools and even internal AWS services built on top of Lambda. So it went from an experiment to a tool that companies of all sizes, from startups to enterprises to mid-sized companies to even consultants, all sort of companies. So maybe you know iRobot. How many of you have a Roomba bot back home that clean your house? Well, I have a couple of them, and whenever they talk to the cloud, they're actually talking to AWS Lambda, and they now have more than 2 million of these bots around the world that talk to their serverless backend. And they do more, if I remember correctly, more than 1,000 deployments of new software every day in their backend. So I want to show you how, also iRobot does their deployment in a CI/CD fashion, so every team can deploy to production every day, multiple times a day in a safe fashion. So let's get there. But first, let me tell you a bit about some of the patterns that we see, some of the different ways you can use AWS Lambda. So for example, you can now bring basically every code you want. Okay, when I say bring your own code, if I told you bring your own code a year ago, I would have said like Node.js and Go and Python and Java and a couple more. But now you can bring any code. Okay, we have developed a functionality called custom runtimes. So if your language is not supported natively by Lambda, you can build your own custom runtime that supports your programming language. Okay, so we have now customers porting their COBOL mainframe into a Lambda function, because there is COBOL custom runtime they can just reuse whenever they want. So this is enabling a lot of transformation, a lot of innovation. So there is no more Lambda does not support my programming language excuse anymore. So I just encourage you to play with it, any language you like. When you talk about resource model, you can give it from, basically you have a power handle, I like to call it. So you can go from 128 megabytes of memory up to 3 gigabytes of memory. And remember, when you give it more memory, you actually are giving it more compute power and more networking power as well. So it's like a power handle, right? And we talked about cost optimization before, and the most important thing to remember when it comes to resource is that, in the traditional world, if you want something to go faster, you also kind of need it. You need to make it more expensive as well. You need to allocate more resources, and there is no way it will be more expensive if you want it to run faster, or if you need more memory, if you need 4 terabytes of RAM. Okay, it needs to be more expensive. With Lambda, if we have a workload that runs with 128 megabytes of RAM, and it takes, I don't know, 10 seconds, If you give it 10 times more RAM, more memory, more power, it will take it 10 times less to run. So at the end of the day, you're actually paying the same for going 10 times faster. Okay, that's what I mentioned. This never happens in IT. So you can just say, go faster, and you pay the same. So think about this when you think about allocating the right resources to your functions. About authoring, about writing code, well, there are all sort of IDEs supported. I'm going to show you live how to use our cloud IDE called Cloud9. So you can just do everything in the browser, all the credentials, all the authorization, authentication, security is a bit simplified. Of course, if you prefer working offline or working on your local IDE, there are all sort of plugins and toolkits for VS Code and IntelliJ and so on. When it comes to monitoring, logging, we kind of always say it should be a universal, right? So every time you console log in JavaScript or print in Python, or just every time you print something in your runtime, all this data, all these logs are automatically delivered to Amazon CloudWatch, which is our service for logs and metrics and so on. And there you just pay for the storage, which by the megabyte is pretty cheap. So I kind of consider that to be almost free, but remember that's part of the equation. And this is another important concept. Your functions, try to build them to be stateless. Okay, what does stateless mean? It means there is no state between one invocation and the next invocation. It should be, we should be able to scale horizontally to as many concurrent functions as possible, so that you can manage up to millions and millions of concurrent API calls or whatever your functions are doing. So try to do that. Of course, you can use local storage in the function runtime. Of course, you can use memory in the function runtime, but use that for caching. Use that for reusing objects that are heavy to build or to create or to instantiate. But don't use that to handle state, because that's not ideal. You're probably doing it wrong. What about the execution model? So there are a few different ways to actually invoke your Lambda functions. The first one is, we call it synchronous. And it's synchronous in the sense that the result object of your function is sent back to the entity that kind of generated the initial event. And I've mentioned before, everything in Lambda is an event. Even an HTTP call is an event to Lambda. So your Lambda function is literally a function, a Python function, a Node.js function, a Java function, and that function will receive, once invoked, an event object. And that event will contain whatever is the request about. It could be an HTTP request, a new object on S3, a new message on a topic, and so on. So in the synchronous model, you are supposed to return back a response. If you fail for any reason, who invoked you is not, if the HTTP client, if you return a 500 error, the request is gone. There's no way to retry, there's no way to decouple client from server in this case. In the asynchronous model, though, for example, if you put a new file on S3, or if you publish a message on a queue or on a topic, there is a nice decoupling mechanism there, so that we can, first of all, do some retry for you. So if the function fails, we can retry automatically a couple of times. If you fail again, you can put the input event into a dead letter queue, we call it. It could be a queue or a topic, so you can take that event back into the loop eventually for reprocessing. But the idea is that whoever generated the event, the client who uploaded the file or the client who created the message into the topic or the queue, doesn't need to know who is behind that decoupling mechanism. So this is a bit a different way of using Lambda, but it's kind of the best practice, especially if you want to have multiple Lambdas working and talking to each other. Having something in between is the best practice. There is a third way, which is very similar, but instead of one event at a time, you're given a stream of events. So it's stream-based. Think about if you're using Amazon DynamoDB, or if you're using Amazon Kinesis for real-time data processing. So you can connect a Lambda function to your database, Dynamo, for example, or to your data stream, and you will be given new records. So every insert, every update, every delete in the database, or every new record in your Kinesis stream will be given as a batch, and you can choose the batch size. So slightly different, but it's still kind of asynchronous. It's just a different way of providing events to the function. API Gateway is probably one of the most used AWS Lambda integration to build APIs. So API Gateway will create a RESTful interface on top of your functions. So you might even have an API with multiple endpoints. Each endpoint is implemented with a different Lambda function in a different programming language. So you can, again, decouple what the client sees from what the backend looks like. And this is very aligned with the idea of microservices, of having multiple teams handling different parts of the system, and maybe even in different programming languages. But API Gateway is not just that. It actually gives you DDoS protection. It gives you throttling, authentication, authorization, a lot of more advanced features. So if you're building APIs or WebSocket kind of applications, you can check out API Gateway. So what happens when you have one function and then you start having more functions that maybe talk to each other and build something more sophisticated? You can end up with 30, 50, 100 functions. Some of our biggest customers using Lambda have hundreds and hundreds of functions talking to each other or talking to queues and other services. And maybe some of these functions are reading or writing from a database, or maybe they are reading or writing from a queue. Maybe some of these functions are even communicating with a legacy system in a data center, maybe connected with the Amazon VPC to your on-premises architecture. Why not? So it can get pretty sophisticated, pretty complicated to orchestrate all this complex logic. So a couple of years ago, we have announced this service called Amazon Step Function, AWS Step Function. And we have bundled it with an open source kind of language that we provide to you to define states, state machines. So what's a state machine? It's like a series of states that could be in series, in parallel, in loop. You can have fail management. You can have branching. You can have different branches converging into a last one to take a decision. So you can orchestrate your virtual workflows. And in this case, you have a starting point, and then each and every one of these steps can be either a Lambda function, it could be a wait state, or it could be even a direct integration with some of the services, like writing into a database or reading from a queue. You don't have to write that code once again. You can just integrate it. So Step Function is pretty cool. I've actually used myself Step Functions to build a tool for Lambda. So it's a bit meta, it's a bit recursive here, but I've built this tool called AWS Lambda Power Tuning. So what this does is it builds a state machine that solves a problem for you, basically. And the problem is, how do you set up the optimal memory or power configuration for your Lambda functions? It's kind of a wild guess, or try all of them and see who's cheaper, who's faster, which is faster. So with this state machine, you just provide your function as input, and it will run your functions multiple times with different configurations, enough times to get statistically relevant data, and then it will come back saying, hey, for your function with this input, this is the optimal configuration. So you can be data-driven. You don't have to guess or guesstimate. And you can do, all sort of different orchestrations. This is a bit meta again, but if you have a complex workflow to orchestrate, maybe with human interaction, you can have waiting states up to a year. So you can build very sophisticated orchestration mechanism. But let's get into the actual topic. And I don't know what time is it, but how much time we have? We're good. So let's get into that CI/CD topic. So what do we mean by continuous delivery? What do we mean by safe deployments? So let me get there. The idea is we want to deploy new code to production in a safe way without breaking anything. But we want to do it fastly. We want to do it every day, possibly even multiple times a day. Why? Because we have maybe 10 developers. They own different part of the system, different services. And they constantly come up with new ideas, which is great. That's why we hire them. But then you have to tell them, no, we deploy only once every 2 weeks on a Thursday because that's our company policy. Okay, can we do better? Can we deploy every day? Can we automate all of it, basically? And can we do it in a safe way so that even if you really git push a bug to production, you can safely roll back automatically, for example. So let's get there. Let's talk about some of these techniques. But first of all, let's agree on safe. So what can you actually do to try to be safe, even without too much automation? What are the techniques? So first of all, you may want your developers to do pair programming, so they help each other, they come up with different ideas, they kind of compensate each other, and of course, tell them to write unit tests. You want to automate the easy part, the actual business logic of your services. And then you can go a bit better. You can say, OK, let's learn integration tests. Maybe you have a local emulator. You want to emulate the database. You want to emulate some integration moving parts. But then maybe you want to also do code reviews. Okay, who doesn't do code reviews? So you open a pull request. Your colleagues will review it. If there is a problem, they'll probably figure it out. And then we can get a bit more better. We can say, OK, let's automate the integration process. Let's make sure every time you git push something, we actually build or compile, depending on the language, programming language that you're using. If you're using Java, you compile it. And then maybe you build the artifact, so this artifact is ready to be tested, maybe by another engineer. So you have automated the integration part, at least. But we can do better. We can do continuous delivery. So every time this artifact is ready, we can take that and deploy it to some kind of environment. Doesn't need to be production. It could be a dev environment for every individual developer, or it could be a staging environment for a team. Can we do better? Well, maybe every time you do that, you want to run some actual AWS account integration tests. So you are actually running your tests in the AWS account. And this is beautiful with serverless, because every staging or every stage that you have, like dev, prod, pre-prod, staging, team A, team B, team C, every team might have their own staging. Doesn't cost you anything unless you use it. The idea is that if you're not using the system, it costs you zero. So it's really convenient to have even one environment per developer. Then maybe you want to have some acceptance tests for your developers, for your designers, for your testing engineers, whoever help you with the manual process of doing acceptance. And the mantra, the best thing you can do is continuous deployment. Okay, without any human intervention, you have this full pipeline that run tests locally, run tests in a dev account. If everything is fine, deploys to a pre-prod account with automated UI testing, all this stuff. And then when you are certain, you just deploy to production. But can we be 100% sure that if you do all of this, no bugs go to production? I can tell you no, because otherwise I wouldn't be here, and we wouldn't build features to help you with all of this complexity. So what actually happens is that bugs go to production. And this is a pretty illustrative GIF of what actually happens. Okay, maybe you're not the operations person doing this, but when the bugs happen, it's Friday night at 7. You have to go around it and find a way to, not have too many customers impacted, and you end up with all sort of interesting workarounds. And it's not fun. It might look like the guy is having fun. It's not. Trust me. So sometimes it actually works pretty well. You just it works, and you fix it. You are the best in the team. Everybody loves you, but you didn't sleep all night, so you don't want that to happen. You feel good, but you don't want that to happen. But usually it does not really work. Okay, so no matter what tool you're using, no matter how much automation or preparation you have, if they wake you up at 3 a.m., there is a problem, the developer is on vacation, it's really hard. You're going to fix it real quick. So what does a CI/CD pipeline actually look like, and what can we do to do even better than that? So I've mentioned already, CI, continuous integration, is taking every update and building an artifact, like the build phase, or maybe you run some unit testing phase. The continuous delivery, usually you go to production, but by production, it might be any account. It might be a staging account, a development account. Usually, it's delivery because there is some sort of human step or a gate that somebody has to say, this is OK. Maybe a testing engineer, or maybe even the CTO if you are a startup. That's what we did. And again, the mantra is to go straight to production without any human intervention, maybe multiple times a day. Why not? That's the think big idea for us as a development team. So these are the tools that on the AWS platform allow you to do just that. And there are a lot of tools, but there is a couple of simple ways to put them together, and a couple of tools that provide you good defaults. So for example, there is a service called AWS CodeStar that puts all these services together and gives you a CI/CD pipeline already configured and mapped to your Lambda functions. These services are code commit. It's basically like GitHub, but on AWS. CodeBuild allows you to build and run scripts and tests. I'll show you what it looks like. CodeDeploy allows you to actually deploy your functions, and CodePipeline allows you to build the actual deployment pipeline using all these services together. If this isn't enough for you, you can even build, as we saw before, more complex orchestration, maybe using AWS Step Functions. There is actually a repository that illustrates how to do that, how to use, and how to, instead of using CodePipeline, you can use Step Functions to customize as you wish your deployment pipeline in a visual way. When we do infrastructure as code, how many of you are familiar with infrastructure as code, like CloudFormation, Terraform? So for all the others, infrastructure as code is a way to define your applications in a template, in a file, that can easily be used to deploy the same application into multiple accounts or multiple regions or multiples, wherever you want, basically. So at AWS, we do that with Amazon CloudFormation, and we have a special kind of flavor of CloudFormation that we call AWS SAM, which is specifically designed for serverless. So it's still CloudFormation. It allows you to do more with fewer lines of code, basically. It's all open source, and instead of writing these 200 lines of code to define a function, basically you end up with 20, which is much better, in my opinion. So here we are defining a function, and we define it as an AWS serverless function. We define where the code is, what runtime we are using. We define what the function can do, and then we also define what events can invoke this function. In this case, we are defining a proxy API so that every API request under a given API will be managed by this Lambda function. But you can map every endpoint, every path of your API, even every method like get, post, put to a different Lambda function if you want. And at very large scale, that's actually the best practice. Try to map individual resources and methods to individual functions that can scale independently and can be optimized for the specific request. So what SAM gives you is a couple, like 2 or 3 spatial resources as well. So you can define a serverless function, you can define a serverless API, and you can find a serverless simple table, which is actually a DynamoDB table. But you can define it with like 3 or 4 lines of YAML or JSON instead of 20 or 30. So it's just a convenient way of defining your serverless functions with fewer lines of code. This is even a local tool. If you are using AWS SAM to define your application, then you can use this AWS SAM CLI. It's a CLI terminal tool that allows you to emulate and run Lambda on your machine, on your laptop. So maybe you are offline, maybe you want to run unit tests on your machine. So SAM will do that for you, and will use Docker under the hood to emulate Lambda and API Gateway as well. So you can do local API invocations, and it will use API Gateway and Lambda together on your machine. But let's raise a bit the safety bar. Can we do better? So we have mentioned all the techniques that we can use. So what do we need to get beyond that to do even better? So yes, we want to do infrastructure as code, because that's the best practice. Yes, we want to be smart about monitoring, about collecting the right metrics, about collecting real-time live metrics during a deployment, so that maybe we can go something if something goes wrong. We want to have different data-driven strategies to react to what goes wrong, if it goes wrong. Maybe we want to even customize, maybe with some hooks. If this happens, run this other function, or before actually starting the deployment, run this other function just for third-party tools, integration, or even just to do even more tests before actually starting the deployment. So these are all interesting things. In my opinion, the best thing you can do is to have this functionality of automatically rolling back to the previous version of your code as soon as there is some sort of error. So you can say, hey, this is the new code, but run it only on 10% of the new traffic coming to this API. If anything goes wrong, if there's any error during the first minute, roll back for me. I don't want to do it, just do it for me. So this is real automation, and that gives you like that safety bar, so that I can literally git push whatever, and in a minute or two, it'll be rolled back. So at very large scale, if you have millions and millions of requests per minute, you probably want to allocate not 1%, but 0.01% to this new code and see if anything happens. That's actually what we also do at Amazon and at AWS. So you can use CodeBuild for that. CodeBuild allows you to run your tests and to basically, it's like you give it a script, you give it a configuration file, and you tell it what to do during the build phase. Okay, so the build phase might look like this. You have some environment variables. You have different phases, like, okay, in the install phase, install the dependencies. In the build phase, do some linting. In the actual build phase, run some tests. And when everything is fine, go and build the artifact. In this case, it's using a command CloudFormation package to actually create a zip file, the artifact of your function. So you can customize this, of course. If you're using Java, if you're using Python, this will look a bit different. But the idea is that you can automate and provide all the different steps in your CI/CD pipeline. And the best thing is there is a feature, a functionality of CodeDeploy that integrates with Lambda. So you can say, I want to do a blue-green deployment. I want to choose from one of these strategies, data-driven strategies. For example, we are going to see the 10% every 1 minute, for example. So every minute after the deployment, we will allocate 10% more traffic to the new version of our code. And if anything goes wrong, we want to roll back automatically. So yeah, we can call this blue-green, and this is enabled by a functionality of Lambda, which is called alias traffic shifting. So you have these aliases that point to your function, to the different versions of your code, and you can say this alias is pointing to 2 different versions in a weighted way. So you can say 90%, 10%. That's the functionality, and CodeDeploy does that for you. So this is what it looks like. The deployment starts. You have 90% allocated to the previous version of the code and 10% to the new version of the code. And if everything goes all right, you go on, and 60-40 and 50-50, and at some point, 100% of the code of the requests are being managed by the new version of your code, and the deployment is succeeded. But what happens when things go wrong? If we build this, it's not for the happy path. The happy path is beautiful. If we build this, it's because things break. Okay, so let me show you what happens when things actually break. And I hope I have at least, yeah, we have enough time. Great. So I have a serverless application. It's actually an API. It's super simple. It's one endpoint. Can you see at all? So it's /test. It's a get endpoint. Let me show you what it does. It doesn't do much, actually. Whoops. Wrong. Here. So I'm calling this /test endpoint. And what the endpoint is doing is just, I'll show you the actual code in Node.js. The endpoint is reading from a database and coming back OK if everything is all right, and KO if something is wrong. Okay, it's doing almost nothing. But let me show you what the code looks like. So first of all, I've defined my serverless application in a YAML file. And here I have my serverless function. I'm using Node. I have my policies. I have some environment variables. And then I'm defining the event /test. It's a get method, so nothing crazy here. But then I've also defined this configuration here, which is saying, hey, use the live alias when you deploy. Use the live alias to do traffic shifting, and use the linear 10% every 1 minute deployment strategy. So every minute we give 10% more, and monitor these 2 alarms. And if any of these 2 alarms comes up with a problem, with an error, roll back. Okay, that's how you do it. As simple as that. And down here, I'm defining the 2 alarms as well that basically just monitor the number of errors generated by this new function. Okay, so where is that? Yeah, there is some. Yeah, so the metric name I'm monitoring is errors, basically. But let me show you the code. The code isn't doing really too much. So we are initializing some clients. We are using DynamoDB. We are reading the table name from the environment variables. We have a little utility to create the response with the status and the body of the response. Then we have another utility function to actually go and read from DynamoDB. It doesn't matter what we are reading for the purposes of this demo, but we are reading from a database. Then we have the actual, we call this the handler of your function. And the handler comes with an event, a context, and a callback. Actually, the callback is a bit older. I could use a new syntax, with async await and with the beautiful new JavaScript stuff. This is a bit of an older code base, but it doesn't matter. So what we're doing is we are preparing the query, we are running the query. If everything goes right, we return. If there is an error, we return item not found. If everything is right, we return 200. If there is any problem with the callback, we just return 500. Okay, so that's no business logic almost. It's 20 lines of actual code. So let me show you. And here I am using. So if you didn't notice, here this is the Cloud9 IDE in the cloud. I'm not using VS Code or anything. This is running in the cloud, and it comes with a CLI. I have my terminals here. So I've written a couple of scripts that will help me demonstrate what we're doing. So I'm going to poll our endpoint. What's the name of it? Okay, bash scripts poll, and then I need the endpoint in input. Okay, so this script is polling our endpoint maybe a few times a second, and then I have another script that is tailing a local file with some, what is the response and how long did the response take to come back. So just to show you what's going on, and now we are going to do a deployment live to see, what changes during the deployment. So let's imagine that our favorite developer will go and introduce a very nasty bug like that. Okay, that's a very bad bug. That's 100% of the times we are going to fail the request. No matter what was the input, we are just failing, okay? So this doesn't happen very often if we have pair programming, if we have code reviews. You probably can avoid this, but I want to show you what happens in the worst case ever, where 100% of the new requests are going to fail, okay? So this is my new code, and what I'm going to do is I'm running another script that's doing the deployment for me. And this script is not doing too much. It is using some variables, packaging, creating the artifact, and deploying to production, okay? So I'm not actually integrating everything into a CI/CD. I'm just, deploy to production, just to show you that you can handle all sort of cases even without a CI/CD. So let's go and deploy to production. We have introduced an error. We are going to monitor the polling. Let's see, maybe in a few seconds, some of the requests, we expect roughly 10% of these requests to fail, right? It's because we are using a 10% every 1 minute data-driven strategy, and we are failing 100% of the times in our new code. So at some point, it should actually fail. Let's wait for it. So let me show you what's happening under the hood. In our AWS account, I'm using Amazon CloudFormation for the deployment. And at some point, we're going to see some new events happening. So let me see what's going on. Yeah. So this is our stack. I'm waiting for, so it started already. So if I click here, I can already see that the deployment has started, and we are allocating 10% of the request to our new code. Indeed, if I go back here, I see some errors, right? Maybe it's too small to read, but what the different lines are saying is internal server error, because there are no servers, but whatever, it's serverless, right? So 10% of the requests are failing, and what we expect to happen is that as soon as the CloudWatch alarm will raise, CodeDeploy will automatically roll back to our previous version of the code. So let's give it another few seconds. And as you can see here, you can monitor what happened. You could have a pre-deployment validation, a post-deployment validation to run your custom code. And as you can see, it already happened. Okay, it detected a failure. It's telling me the deployment is canceled to an abort request. And if I go back to my polling, I'm already 100% okay, right? So is this safe? I think it's much safer than what most people do. You can integrate it with the CI/CD pipeline, or you can do it with deploy to production manually. So you're free to choose. But the best thing is, in the worst case, even if your new code fails 100% of the time, you go back in a minute without any, waking up somebody, which is what usually happens. So in a typical use case, you want to have 0.00% of your traffic, and you're not failing 100% of the time. So depending on your scale, you may want to allocate different percentage of your traffic to this new, potentially broken version of your application. And let me stop this. I have another script that is doing some statistics. So I've started polling much earlier than the deployment started. So I roughly 10% of the requests should have failed, but since we started polling until I stopped polling, only 2% of the requests failed. So only 13 requests failed in that roughly 60-second interval where everything was broken. Okay, I think that's acceptable. If it's not, if for you 13 requests in a minute is too much, you can lower the percentage. So that's up to you. Cool. We have a few minutes left, and that's all I had for you today. I hope you enjoyed breaking production live on stage with me, and in a safe way, though. So thank you for coming. So do we have time for questions?
Yes. Anybody in the audience have a question? We'll start with the audience first. Please raise your hand. I'll run the mic over. Oh.
1 second. Is it on? We are live. Yes.
Okay. When do you want to use Fargate instead of Lambda?
Sorry, can you repeat?
When do you want to use Fargate instead of Lambda?
Fargate instead of Lambda. So for those of you who do not know Fargate, some people consider it serverless, some people do not. Basically, it's a way to deploy Docker containers on Amazon ECS or managed Kubernetes on AWS. But instead of managing the cluster, you don't see the cluster. We take care of that for you. You only think about Docker containers and things like that, which is a bit more serverless than managing the cluster yourself. So when do you use Fargate instead of Lambda? Well, there are a few use cases that make sense. Basically, if you need more than 3 gigabytes of Lambda or of memory, for example, Lambda does not allow you to go beyond that. So if you need a terabyte of memory for some reason, that might be a better use case. Or if you need to run your workloads for, I don't know, half an hour or 5 hours, every Lambda invocation has a maximum timeout of 15 minutes. Okay, if you have a microservices architecture, each individual microservice shouldn't run for more than 15 minutes, so that's the idea. But if you have, I don't know, a video processing use case that, the only thing you can do is running on a long-running server, maybe Fargate is a better use case for it. Or there are other use cases where you have like operating system dependencies that are specific to, I don't know, like Fortran or C++ or some very custom dependencies that you would need to install in the operating system. Okay, in that case, I'm not saying it's impossible. I'm saying with Lambda, it's a bit more work. So some folks consider Fargate a better fit for it. So you just prepare Docker image, you install whatever you want on the operating system, and then you just deploy to production. You run it for an hour, 5 hours, or 10 seconds with your custom dependencies. So in Lambda, that is possible, but you still have some limitation, for example, on how big can you be your deployment package, which is like 500 megabytes or so. So for example, if you're deploying machine learning models that are 2 gigabytes in size, okay, that might be a bit tricky with Lambda, and Fargate might be a good use case for it. So there are use cases, as I said before, it might be 10 or 15% of what's up there left that serverless isn't handling yet. Cool.
So one of the related conversations that we've been having in Twitch is how to work around this 15-minute timeout limit in...
That's a good one. So there are different ways to overcome the 15 minutes limitation. One is, it depends on the use case, but if it's a very simple use case, you might even want to, within the function itself, there is a context variable. You have the event and the context for every invocation, and in the context variable object, you can ask it how many milliseconds have I left in this invocation. So some people are doing hey, when you have less than 5 seconds left in your 15 minutes invocation, stop everything you're doing and re-invoke yourself, and then you can run for another 15 minutes. Okay, this is not ideal, and recursion is tricky, whatever you do, especially with architectures. A better way, in my opinion, would be to decompose these, I don't know, 25, 30, 60 minutes of computation into smaller chunks, and maybe orchestrate them with the state machine visually to say, first do this for 5 minutes, and then split, maybe in parallel, and run for another 6 and 8. And when they're done, go back and do some final computation for 10 minutes. Okay, this way it's much easier to decompose and to build an orchestration state machine instead of having one function running for half an hour, which you can't. So I hope it makes sense for you. And if you have other questions, I'm here or at the booth later. Thank you, everybody, for coming.
Wait, one quick last question from
Okay.
Twitch. Stamso says, would you say that SAM is at the same level of maturity as serverless?
You mean the serverless framework? So that is another good question. It depends on what you're doing, what you're building, and what service you're using, what plugins you're using. So basically, the serverless framework is a framework that was born maybe more than 2.5 years ago, and it really allowed the community to grow really quickly because it solved a lot of challenges for serverless developers. AWS SAM is what I've shown you, and it's another framework, or better, a CloudFormation extension that allows you to do almost the same things, only on AWS. So there are considerable similar things, let's say. It really depends on what you're building. So if you're using, I don't know, a special plugin that is available only for serverless framework and it's not available on SAM, you might want to stick to the serverless framework. Or if you're using other vendors, it might be a good fit because it supports multiple vendors. I haven't seen too many people doing that, but if you are, that's for you. If you are only on AWS, if it's a new project, if you want to use some of the new cool features like the safe deployments or some of the new stuff that SAM is integrating as soon as possible when they go live, I think SAM is getting pretty much mature as well. So it depends as usual. I would do case by case. There is no one size fits all decision in my opinion. Cool. Thank you again.